Welcome back to another explainer. Okay, today we're diving into something that is literally a paradigm shift in computing. We're going to be exploring Anand and Vemula's recent unboxing of the NVIDIA DGX Spark. We are going to break down exactly what makes this device the world's first true personal AI supercomputer and how the mind-boggling engineering packed inside it is going to completely change the daily workflow for developers everywhere. Let's get into it.
1 petaflop. Just let that number sink in for a second. This massive, almost incomprehensible figure represents the sheer, raw performance packed into the single device. Now, reaching a single petaflop of computational power used to require, massive server rooms and crazy industrial cooling infrastructure. But now, it's a localized threshold specifically tuned for the incredibly demanding math required by artificial intelligence.
And here is the absolute kicker. That entire 1 petaflop of power weighs just 1.2 kilograms. It literally fits right in the palm of your hand. It's an unbelievable leap in modern engineering, taking room-scale supercomputing power and physically condensing it down into a form factor that's actually lighter than most standard laptops. It's just wild.
All right, moving to section 1, a supercomputer in your palm.
So the really crucial point here is understanding exactly what this machine is. It is not just some high-end PC, but a true personal AI supercomputer sitting quietly right on your desk. The DGX Spark establishes a completely new category of hardware. It's not a gaming rig retrofitted for AI, and it's definitely not a remote server you have to wait in line to share. It's a dedicated, highly specialized machine designed from the ground up for one single purpose: accelerating your artificial intelligence tasks locally.
Let's move to section 2, unboxing the hardware.
At the absolute heart of this beast is the Grease Blackwell GB10 superchip. That is the engine driving that 1 petaflop of performance. And it is paired with a massive 128 gigabytes of unified memory, which is absolutely vital for loading large models without hitting any annoying bottlenecks. And finally, rounding out the hardware suite, we've got Connect 7 networking ports to ensure all your data flows in and out with incredibly high bandwidth.
Next up, section 3, the software brain.
Now, you'd probably think setting up a supercomputer would be a total nightmare, right? Well, the setup journey here is surprisingly streamlined. It maps out exactly how you go from booting up to actual processing. Step 1 brings us into the DGX OS, which is comfortably Ubuntu-based, so it's going to feel super familiar for most developers. Step 2 is loading in the heavy hitters: NVIDIA AI Enterprise and the CUDA software stack. That's what unlocks the specific AI capabilities of the Blackwell architecture. And then finally, step 3 is running that satisfying Hello World benchmark just to prove the system is alive and crunching numbers. Which brings us to section 4, running a local LLM. Watching this tiny device just chew through a local large language model seamlessly, it totally proves that this is not just some tech novelty. It is a serious workhorse. We all know LLMs are notoriously memory hungry, often forcing developers to rent really expensive cloud clusters just to get them to run. But because the DGX Spark leverages that 128 gigs of unified memory, it handles the model locally during that benchmark run without even breaking a sweat. And that leads perfectly into section 5, moving off the cloud. This is where we see a massive paradigm shift. Instead of relying on the traditional cloud, dealing with remote servers, internet latency, dropping connections, and those super slow queues, the DGX Spark gives you direct, immediate access for local fine-tuning. It's basically total computational independence. As Anand points out in the source unboxing, this hardware fundamentally changes the game. Whether you're a researcher, a developer, or just a hardcore AI enthusiast, this device untethers you from cloud dependencies completely. It gives you total, absolute sovereignty over your own fine-tuning processes. So to wrap up today's explainer, I really want to leave you with this to think about. With 1 petaflop of power completely under your control, sitting quietly right there on your desk inside a 1.2 kilogram box, what is the very first thing you would create? The barrier to entry for massive local AI computation has literally just been shattered. Thank you so much for joining me today to unpack this incredible leap in personal computing, and I'll see you in the next one.